We will discuss systems development in this session. We will define what is systems development, explain the overall process of developing new systems, explain the differences between system development methodologies, discuss the components of a feasibility analysis, list the different types of programming languages used to develop software, clarify some of the issues surrounding the development of mobile applications, compare the build versus buy decision, and identify the 4 primary implementation policies. So systems development could be seen as the simple process of writing programs to solve the needs of the users. However, in reality, this process is not simple. End users may not know what they want. End users may know what they want, but lack the technical expertise to bring the idea to life. So systems development actually undergoes the different stages through its life cycle. It starts with the preliminary analysis to understand what needs to be done, what is the problem that we are trying to solve, and then understand the technical, financial, and operational feasibility of the solution. Do we have the technology to make that happen? Do we have the sufficient finance to sponsor it? And what could be the issues in terms of operationalizing it, in terms of the training required, in terms of specialized infrastructure, etc. Once it has been identified that this can be done and this is the problem that we are going to solve, we start doing the system design. That is the technical architecture or a blueprint of what will be the components of the system and how they are going to interact with each other and how they will eventually solve the problem, going through the different stages. Once the system design is ready, it is programmed, actually writing the software code to make that system come to life. Once the programming is done, it is tested for quality. It is ensured that it is actually doing what was proposed to be done. Once it passes through the testing, there are several types of testing basically. You have technical testing, logic testing, user acceptance testing, etc. Once it passes the testing, we implement it. And the implementation actually involves deploying it in the actual operation. Once it is in operation, we undertake the maintenance of the systems to continue to deliver what is expected of the system to do. If there are issues, the cycle continues of preliminary analysis to maintenance, or sometimes you may want to add more functionality, so you may want to update or upgrade the systems. That's a very common intuitive method of developing systems. Now in the current time, we have different ways of systems development. One of the common method is the rapid application development, which focuses on quickly building a working model of the software, getting feedback from users, and then using that feedback to update the working model. So here we kind of keep developing a minimum product cycle after cycle and keep introducing it to the user, and after receiving the feedback, you keep on updating and upgrading the design and the development. Unlike the conventional life cycle method, where it may take very long time for the product to be built and very rigid way of developing it. It's like there is no version and there is a version 1 after a long time. Here we have like rapidly multiple versions which are released in short span of time. Another one is the agile methodologies. This is tinkering further the rapid application development method by allowing the changes in the system design while we are still developing the system. So basically these are bunch of or collection of methodologies, and these are very common these days. The reason for agile methodology is, one, the world is evolving fast, the technology is evolving fast, the requirements may change while the product is being developed. So in the conventional methods, once you have done the system design, you do not deviate from it. Here you welcome the feedback, you modify the feedback, and collaboratively develop the product in a shorter time span and accept changes. Besides that, we have what we call as the lean methodology, which focuses on taking an initial idea and developing a minimal viable product. So here we have an idea, we quickly come up with a prototype, we code it, we evaluate the feasibility or maybe the performance of the tool or the device or the system that we are developing, and collect data on it. From data you learn about it and ideate to come up with a better and superior version of the product. So possibly the final end form of the product may not necessarily be decided very precisely, but there is a vision that needs to be accomplished. The how part is kind of done based on data and the learnings that are done over the development period. Now, regardless of the system development, the scope and objectives of the new system should be investigated to determine feasibility. New applications normally originate from end user requests and are weighed against the other requests for information system resources before approval to develop the system is granted. So basically in the organization also multiple demands are put to develop new tools and new solutions to the existing situations, and they need to be prioritized and weighed, and then the development of the system should be granted. And they require those typical feasibility studies, technical, financial, and operational. So in order to ensure that the new system would be of great benefit to the organization, then other competing requests for proposals. So the three major areas of feasibility study are economic, technical, and operational. Economic is same as financial feasibility. Oftentimes the product may be great in functionality but might not be so good in design. So there are different what we call philosophies within which these systems are developed, which involve design first philosophy, it could be mobile first philosophy, it could be web first philosophy, and in the current time the design is a key differentiator. Design is not just about aesthetics, it would be about how people engage with the system. And it could mean different things to different people. In many ways, building an application for mobile device is exactly the same as building an application for a traditional computer. Understanding the requirements for the application, designing the interface, and working with users are all steps that needs to be carried out. But mobile has certain limitations in terms of the screen size, in terms of how much memory or how much computing power it can carry, in terms of how long the battery will last in the device, and how big or small a font we can allow, or what kind of images that we can use on the mobile devices. Programming is the process of creating a set of logical instructions for a digital device to follow using a programming language. The process of programming is sometimes called coding because the developer takes the design and encodes it into a programming language which then runs on the computer. One of the very important decisions that organizations often have to make is whether they should build the system themselves or should they buy it from the market off the shelf. So this is a decision, it's a very classic problem in the systems development world, which is called as the build or versus buy decision. The advantages of purchasing software from an outside company is it is less expensive to purchase software than to build, because it is built and scaled for a whole lot of customers. So it is more efficient, coded once, deployed multiple times. When the software is purchased, it is available much more quickly than if the software is built in-house, because you need to just configure it and start using it, whereas development involve testing and then coding and then iterating on the versions before you actually finally release the product. The disadvantages: first, the same software you're using can be used by your competitor, so it may not create any competitive advantage. Secondly, if the software is purchased from a vendor and then customized, you will have to manage those customizations every time the vendor provides an upgrade. So your customizations may break in case the vendor upgrades the product. Also, you may not be able to exactly do what you want to get done using the software, because the product vendor did not make provisions for those flexibilities. The implementation and the maintenance phase of the systems development, it is not just deployed in one go or one shot, because it requires adoption by the organization, and we would like to de-risk from having any discontinuities that may emerge because of the switch over to the new software. So there are primarily 4 popular methods which are used in case of low risk, low complexity projects. You may just do a direct cutover, replace the old system with the new one. Other is the pilot implementation. You do not do a full scale implementation, you just do a partial implementation, get feedback from the end users, and then you expand the scope of it. Other option is the parallel operation, where you allow the old and the new system both to work together simultaneously, and the users can choose which one they want to use. In case the new system fails, they can always revert back to the old system. And other is the phased implementation, where you introduce the product in multiple phases. So key takeaways: software development is about solving business problems. Developing new software application requires several steps, from the formal SDLC process to more informal processes such as agile or lean methodologies. I would not really call them as informal, but it is more flexible and versatile and more accommodative in the product development. In end user computing, software development happens outside the information technology department. Conducting a feasibility analysis is important, irrespective of what methodology we use, to ensure that the product or the system will be a good investment. Programming languages evolved from low-level machine-specific languages to higher-level languages that allow a programmer to write software for a wide variety of machines. They are a lot more flexible. Earlier, the programming languages were hardware and operating system specific. Now we have a lot more flexibility on those. Most programmers will with software development tools to make the software development more efficient. Some companies choose to purchase software to save development costs and speed. Implementation. When implementing new software applications, there are several different types of implementation methodologies that must be considered. Thank you.